Pressure is the ratio of force acting on a body over unit area. Just take the example of pushing a nail into wooden plank. If you try to push it through blunt end, it becomes difficult to push. You have heard of air pressure inside tires. We know we need to maintain standard pressure in wheels for proper functioning. When there is less air, it becomes difficult, tire gets punctured. Even having more air also leads to bursting of tires. Atmosphere exerts pressure on us, which is equal to blood pressure inside our body. So atmosphere pressure is very much important to keep life on earth. The SI unit of pressure is Pascal, that is Newton per meter square. As we go higher and higher up in the atmosphere, the pressure decreases, and if we go in space, it becomes extremely difficult to withstand the variation in pressure, because inside pressure is more and the pressure outside in the atmosphere is less. In order to avoid the imbalance, the astronauts they wear space suits when they go to the space. So remember, pressure P is the force acting over unit area. When the area of contact is reduced, the impact of force will increase. That is nothing but the pressure. So it is clear that astronauts wear space suits in order to have the comfortability in space. Otherwise, blood veins may burst out. Even you might have heard, if you climb a mountain, at the top of the mountain, many will have nose bleeding. This is because of the veins which are present in our nose, which are very soft. They burst out due to low pressure outside. So pressure can be experienced in solids also, liquids, and even in gases. Always a liquid and gas move from a higher pressure region to a region of low pressure. Be knowing, even in our LPG cylinders, gas is stored under high pressure so that it will be in liquid form. When it is connected to the stove by the means of pipe, when it comes out due to low pressure, it becomes again gas. Even in the liquids, as you observe through the pictures here, as you go deep inside, the pressure will increase. The pressure increases with depth. So in a column of water, at the topmost position, pressure will be less, and the bottommost position, pressure is low. Just observe the figure where three pipes are connected, where the force of water coming out is less at the topmost position and it is maximum at the bottom, because pressure increases with depth. The SI unit of pressure, Pascal, was named after French physicist and mathematician Blaise Pascal. 1 Pascal is fairly small amount of pressure. Some items such as the tip of a nail or the edge of a knife are designed with a very small surface area in order to maximize the pressure by force. Submarines have to be specially designed to withstand high pressures when they are deep underwater. Air pressure is often measured with a device called barometer. Most barometers today measure air pressure in millibars, and the pressure or the atmosphere pressure at sea level is 760 millimeter of mercury. Changes in the air pressure are very important for weather forecasting because they can indicate changes in weather. Just try to go through the activities which are given in a textbook. And in the next slide, there is a video which will explain you the differences between force and pressure. Have a look on it.
Forces you see in daily life. You pushing a box, your weight, which is a force acting downwards, hammering a big nail into the ground. All these forces, if you notice, are acting perpendicular to the surface. A force exerted by an object perpendicular to the surface is given a special name. It's called thrust. It's the total force acting perpendicular to the surface. What will be the unit of thrust in the SI system? Can you guess? You should have got this one. Thrust is nothing but force. So the SI unit of thrust will be the same as that of force. Newton. The SI unit of thrust is Newton. What's pressure? Now I don't want the definition or the formula. I want you to understand it. Let me give you a couple of examples. Take a pencil and keep it between your thumb and index finger with the tip touching the index finger and the other end touching the thumb. Now apply equal force from both ends towards the pencil for a few seconds. Release the pencil and observe the two fingers. To be precise, observe the depression you see in the fingers. You'll notice that the depression in your index finger is much more as compared to the depression in your thumb. Why does that happen? Before we answer that, let me give you a second situation. When you stand on loose sand, you see that your feet go deep into the sand. Now, if you lie down on the sand, will you go just as deep into the sand? No, you won't. But if the force exerted in both the cases is the weight of your body, then why is the depth in the first case more? That's where the concept of pressure comes in. Pressure is nothing but the force per unit area. If we're talking about thrust, it would be thrust per unit area. If the thrust is constant and the area is more, then the pressure will be lesser. And if the area is less, then the pressure will be more. Pressure is inversely proportional to the area on which the thrust is applied. Now we can understand the two situations in terms of this formula. What happened in the first situation? As we apply an equal force from both ends, then as per the Newton's third law, the pencil will also apply an equal and opposite force on the fingers. But the depression was more on the index finger. That's because the area on which the tip of the pencil applies a force on is lesser as compared to the area on which the other end of the pencil applies a force on. As the area is lesser, the pressure is more. And that's why the depression is more. Can you understand the second situation using this concept? In the second situation, the area on which your feet lie is lesser as compared to the area on which your entire body lies. And that's why the pressure is more when your feet are on the sand as compared to when your entire body lies on the sand. Which explains why the depth here is more. What is the SI unit of pressure? As it's force over area, it would be Newton per meter squared. This is the SI unit of pressure. And this is also called as Pascal. 1 Pascal is 1 Newton over 1 meter squared. This has been named after a famous scientist called Blaise Pascal who had conducted extensive studies in this area of science. Let's quickly recap what we learned. What's thrust? It's the total force acting perpendicular to the surface. And what's pressure? It's the thrust per unit area. If the same amount of thrust is applied on a lesser area, then the pressure will be more.